Partial fractions. Partial fraction decomposition is what happens when we take a rational expression and make it easier by writing it as the sum of fractions. So this says 2 fractions, but could be 3 or 4 or so on with first degree denominators. So instead of x plus 7 divided by x squared minus x minus 6, we take the denominator and factor it into x minus 3, x plus 2, and then we solve that basic equation to determine the values of 2 and negative 1. So each fraction on the right is called a partial fraction. So we have 2 partial fractions in this case. Together their sum is called the partial fraction decomposition of the left side. Now it's very important to note that we can only use partial fraction decomposition when the degree of the numerator is less than the degree of the denominator. So if this were x cubed plus 7 in the numerator, we would first try to do some long division, which we'll do some practice with today, or we wouldn't be able to rewrite. I wanted to include an overall steps page for you to reference. I recognize that none of this is going to make sense to you yet, but let's kind of talk through the basic steps. So step 1 is if you have a degree in the numerator that's greater than or equal to the degree of the denominator, we have to use polynomial long division to divide and obtain something simpler. So it's going to give you a polynomial, and the remainder will be rational, and therefore we can use partial fraction decomposition on that. Step 2 is we're going to factor the denominator, just as we talked about on our last slide. We're going to factor it into linear factors and to quadratic factors. And then we're going to write each linear factor up to the degree. So for each one, we're going to write some constant a. So we're using a1, a2, and so forth. But really, when we do this, we're going to use all of the letters of the alphabet to make it easier. We're going to write a constant over the power, the first power. Now, if it's a second power, we're going to write a new constant over the second power of that factor, and so on, all the way up to however many powers of that factor we have. And then we're going to do the same for a quadratic factor. And what I want to point out about a quadratic factor is, again, we're going to use bx plus c in the numerator. So instead of just a in the numerator or one constant, we're using a linear equation in the numerator, which is bx plus c. Once we have everything rewritten, then we're going to solve the basic equation. And there's 2 basic ways to go about solving that equation, and one is to substitute the zeros of the linear factors or other convenient values into the basic equation. And what we're trying to do is just solve for a and b and c and all of the constants or variables that we used. And if necessary, I'm going to show you the other method to solve, which is to expand out the basic equation and collect all of the constant terms, all of the linear terms, all of the quadratic terms, and so forth. So we're going to look at all of that together, but this is a good overview page that will make much more sense once we've practiced all of the parts. We're going to do our best to break this process into manageable bite-sized pieces. So the first thing we're going to do is just practice writing the factors. So looking at my first example, I have 3 divided by x squared minus 3. I can see just by looking at it that the degree in the numerator is 0. The degree in the denominator is 2. 0 is less than 2, so we're fine. So I'm just going to rewrite then by factoring the denominator. So it looks like I can take a common factor of x out of both terms and get x minus 3. Now when you rewrite this, you're going to write some constant of a and some constant of b, and I know there's going to be 2 fractions because I have 2 factors. Now each of those are linear factors, so I've got a divided by x and b divided by x minus 3, and that's all I have to do. So yes, there are more steps, but we're going to stop there for now. We're just practicing writing the factors. Let's look at the second example. Again, the degree in the numerator is 1, the degree in the denominator is 2, so we can apply this process. I'm going to rewrite x minus 2, and then x squared plus 4x plus 3 can be factored into x plus 3, x plus 1. And again, those are both linear factors. So when I rewrite this, it's going to be a divided by x plus 3 plus b divided by x plus 1. Let's take a look at the third one. This degree is 1, this degree is 2, and a lot more than 2, right? So the degree is certainly greater in the denominator, so that's good. Now I don't have to do any factoring here. We can see it's already factored, so the difficulty here comes with the fact that we've got a divided by x, and then we have a repeated factor, and remember that means it's just one constant, b, divided by x squared. So this is the first time we've had a repeated factor. So when you have a repeated factor, you're not going to change what happens in the numerator. And again, remember before, instead of b, we looked at a1, a2. You're going to find that gets very confusing. So I'm just using b as some constant that I'm going to have to solve for. So that takes care of x and x squared, and now I've got 2 of these. So again, I have another repeated factor, but if you'll notice, the factor itself is x squared plus 3, which is quadratic. So it's going to be cx plus d in the numerator, and in the denominator, x squared plus 3 to the first power. And then I've got another one, ex plus f, and then x squared plus 3 quantity squared. So that one was a little bit tricky. We had 2 different things going on. First of all, we had repeated factors, 2 x's and 2 x squared plus 3's, and we had our first quadratic factor. Let's take a look at our last one. This one's definitely the trickiest because if you'll notice, the degree of 3 is greater than the degree of 2. And we said, well, if that's the case, we're going to have to try doing polynomial long division. So I'm going to take 2x cubed minus x squared plus x plus 5 divided by x squared plus 3x plus 2. Now recall when we learned how to do polynomial long division, we were focusing on first terms. So x squared goes into 2x cubed, or what happens when I take 2x cubed divided by x squared? I would get 2x. And then I'm going to take 2x times all of those values. So 2x times x squared is 2x cubed. 2x times 3x is plus 6x squared. And 2x times 2 is plus 4x. And then remember, I'm going to subtract all of it. Well, I'm going to turn it into plus and then change the sign of everything. So 2x squared and negative 2x squared cancel. I get negative x squared and negative 6x squared, so that's negative 7x squared. I get x minus 4x, so 1 minus 4 is negative 3x, and then I'm going to bring down the 5. And then I'm going to repeat that process. So x squared and negative 7x squared gives me negative 7. So I'm looking at the first term. And then I'm going to take everything times negative 7. So I'm going to get negative 7 times x squared is negative 7x squared. Negative 7 times 3x is negative 21x. Negative 7 times 2 is negative 14. And then I'm going to subtract this. So I'm going to change it to plus and change all of the signs. And that's going to leave me with the 7x squareds canceling. I get positive 21 and negative 3, which is positive 18x. And then I get 5 plus 14, which is 19. So what I have is this turns into 2x minus 7. And then I've got the remainder of plus 18x plus 19 divided by, and instead of x squared plus 3x plus 2, I'm going to factor that into x plus 2, x plus 1. So x plus 2, x plus 1. Now, I still haven't finished because it says to please rewrite it with fractional, partial fraction decomposition. So I'm going to only take the 18x plus 19 divided by x plus 2, x plus 1, and rewrite that as a divided by x plus 2 plus b divided by x plus 1. So we don't have to worry about this first part because that's going to be very straightforward. It's just a polynomial now. Now that we know how to do the first step, which is to rewrite with coefficients a, b, c, and so forth, let's talk about how to actually solve for those coefficients. So no matter what, there's two basic ways to go about solving. And I'm going to show you both of them for example A, and then let you choose for the next example. And typically one of them is going to make more sense to you than the other. But the very first step is the same no matter what. And the very first step is to multiply everything by the original denominator. So that means every single fraction. Now I don't always show this step, but this is what you're doing. You're looking at the original denominator, which was x squared minus 3x, which if you'll recall, we wrote that as x times x minus 3. We're multiplying everything by that denominator. And the reason that we do that is the original fraction, we're going to be left with only the numerator every time. On the right-hand side, if I cancel out those x's, I'm left with a times the quantity of x minus 3. And for my second fraction, taking out x minus 3, I get plus bx. Here is where I have a choice to make. Choice 1 is to use nice values. So nice values include zeros, anything that would make a factor equal to 0. And so in this case, nice values, I'm going to let x equals 0, because if I let x equal 0, you're going to see, and again, how do I know 0? Because I'm looking at these two values that involve x, and if I let this x equal 0, b is going to go away because I'm going to have 0b. That's how I'm making that choice. So 3 is equal to a, x is 0, b times x is 0. That gives me 3, and then a times negative 3, so negative 3a, and then plus b times 0, well, that's going to go away. Continuing to solve for this, I get negative 1 is equal to a. And then I can solve for b by let x equal 3. Well, now, how do I know x is 3? Again, I'm looking here and saying if I let x equal 3, that's going to be 3 minus 3, which is 0, and a is going to go away. So 3, and then a times 3 minus 3 plus b times 3. 3 minus 3 is 0, so I have 0 a's, so I get 3 is equal to b times 3, or 3b. Dividing by 3 on each side, I get 1 is equal to b. So don't just stop here. A lot of students stop right there and say, okay, I did all of the steps that you wanted, and you did, but what I need you to do now is rewrite this as, instead of a, negative 1 divided by x, and instead of b, 1 divided by x minus 3. So my original fraction can be rewritten in the partial fraction decomposition of negative 1x plus 1 divided by x minus 3. Now, I told you I would show you both ways. So number 1 is to use nice values. Number 2, which I'm going to end up deleting just to have room probably, is to use a system of equations. So use a system or collect like degrees. And we're going to do question 1 in that way again, just so you can verify that you're going to get the same solution, and then you can choose how to do the second example. So in this way, I'm still starting with this equation, and I'm going to go ahead and distribute the a. So I have ax minus 3a plus bx. And then I'm going to put them where all of the x terms are together, all of the constant terms are together. If I had quadratic terms, I'd stick all of those together. And that gives me 3 is equal to ax plus bx, that's all my x terms, minus 3a. And then what I want to do is I want to think about the left-hand side is technically 0x plus 3. And the right-hand side, if you'll notice, each of those has an x, so I've got a plus b x, and then minus 3a. And the reason that this turns into a system of equations is I'm going to let 0 equal a minus b. I'm sorry, a plus b. Because I'm looking at 0x and a plus bx. And then I'm going to let 3 equal minus 3a, because those are the constant terms. So I'm just looking at the same degrees and setting them equal to the original equation. Now this one, if I divide by -3, because I only ended up with just one variable, I end up with a is equal to -1, which is what I had before. And then I would take that -1 and plug it back in to get 0 equals -1 plus b. Add 1 to each side, I get 1 equals b, and that is what I had before. So either way, I end up with the same solution. So it's up to you which way you like best. I would like for you to go ahead and work ahead of me and try that second question. Use either method that you want. So use the nice values or use the system. Both of them will result in the same solution every time. So I'm going to go ahead and start going through the second one. First step is to multiply everything by the denominator, which was x plus 1, x plus 3. And on the left-hand side, that gets rid of the entire denominator. So that gives me x minus 2. And on the right-hand side, I end up with a times x plus 1. And then get rid of the x plus 1, so plus b x plus 3. I obviously don't have room to do it more than one way, so I'm just going to do it using the nice values way. And that would give me let x equal -1, because again I'm eyeing that x plus 1, that would give me a 0. So that gives me, now be careful on this one. This is still an x, so I see a lot of students mess up right there and leave it as x minus 2, but it's actually -1 minus 2 is equal to a times -1 plus 1 plus b -1 plus 3. So on the left-hand side, -3. -1 plus 1 is 0. -1 plus 3 is 2, so I get 2b. And so my dividing by 2, I get -3 halves. Oops, -3 halves is equal to b. And then I would let x equal -3. And again, don't forget to include it right here with this x. So -3 minus 2 equals a -3 plus 1 plus b -3 plus 3. And this side, -3 plus 3, will cancel out, which is why I'm using -3. On the left, -3 minus 2 is -5. And then I've got -3 plus 1, which is -2a. So I divide by -2, and I get 5 halves is equal to a. Remember, back up here, we're replacing a with 5 halves. So you can either write 5 halves in the numerator divided by x plus 3, or you will often see that written as 5 divided by 2 times x plus 3. Either way is fine. Most often you're probably going to see Again, negative 3/2, so I'm going to put a minus here. You're probably just going to see it as 3/2 in the numerator and x plus 1 in the denominator. What I want to do now is start from the beginning of the question and work it all the way through. So we've done some practice for how to rewrite with A, B, C coefficients, and we've solved for those coefficients, and now we want to do it all for the same question. So to begin, I would note that the degree of 3 is greater than the degree of 2, so that makes me not happy at all. So the first thing I have to do here is I have to do long division. So I'm going to divide x cubed plus 2x squared minus x plus 1 by x squared plus 3x minus 4. I'm going to look at the first terms and say, if I took x cubed divided by x squared, what would I get? I would just get 1x. So I'm going to take x times x squared, x times plus 3x, and x times minus 4. Then I'm going to subtract all of that. So I'm going to change it to plus and change each sign. That leaves me with the x cubes canceling, negative x squared, negative 1 plus 4, which is positive 3x, and bring down the 1. And then I'll repeat the process and say, if I took negative x squared and I divided it by x squared, what would I get? I would get negative 1. And that leaves me with negative 1 times x squared, negative 1 times 3x, minus 3x, and negative 1 times negative 4, which is plus 4. I'm now going to subtract all of that, which means I'm going to change all of the signs. That leaves me with 3x plus 3x, which is 6x, and positive 1, and negative 4, which is minus 3. So essentially what I'm saying is I can rewrite this as x minus 1 plus 6x minus 3 divided by, and let's go ahead and factor this denominator, which would be x plus 4, x minus 1. Once I get it to this point, now I can use my strategies for solving. So I'm going to only focus on this portion. And I'm running out of room, so I'm just going to rewrite that portion as a x plus 4, and then plus b x minus 1. That's what I'm going to solve. I'm going to take everything multiplied by x plus 4, x minus 1. On the left-hand side, I will get 6x minus 3 because the entire denominator will cancel. On the right side, a, and then I'll have x minus 1 because the x plus 4 factor will cancel. And then plus b, and then I'll have x plus 4 because the x minus 1 factor will cancel. From here, this is where you get to choose your method of madness for solving this. So I'm going to let x equal 1. And if I let x equal 1, that's going to give me 6 times 1 minus 3 is equal to a times 1 minus 1, which is why I chose it, plus b 1 plus 4. That's going to give me 6 minus 3, or 3, is equal to a times 0, so that goes away. And then 1 plus 4 is 5, so 5b. So dividing by 5, I get 3/5 is equal to b. And then I'm going to let x equal negative 4. And that's going to give me 6 times negative 4 minus 3. And then a, negative 4 minus 1, plus b, negative 4 plus 4, which is why I chose it, so that it would cancel out. 6 times negative 4 is negative 24, minus 3 is negative 27. On the right, I have negative 4 minus 1, so that's negative 5a. Dividing by negative 5, I get 27/5 is equal to a. So when I write my final solution, I will write that 6x minus 3 divided by x plus 4, x minus 1, is equal to a, which is 27/5, and then x plus 4, plus b, which is 3/5, and then x minus 1. And we did talk about before, instead of 3/5, if you want to write 3 in the numerator and 5 in the denominator, you can do that. You'll note that once we learn more strategies as to why we would use partial fractions, it actually makes more sense to keep the 3/5 in the numerator just like that. We're going to finish with a difficult question. We're going to write the partial fraction decomposition of this rational, which has 4 factors, 2 alike linear factors and 2 alike quadratic factors. So this one's going to be difficult, but let's just get started going through this together. If you're feeling confident, feel free to pause and then fast forward to the end to see how you did. So first thing I need to do is to be able to rewrite this correctly. I have x squared, which means I'm going to have an a divided by x and a b divided by x squared. So that's my 2 linear factors. And then I've got 2 quadratic factors. So I'm going to have cx plus d, and then x squared plus 2 to the first, and then ex plus f, and then x squared plus 2 quantity squared. So that's step 1. Thankfully, we didn't have to do any rewrites because the numerator had a smaller degree than the denominator. So let's take a look now at the next step, which is to take everything and multiply it by the original denominator. So on the left-hand side, I have 8x minus 12. And on the right-hand side, my first fraction, 1x would cancel. That would leave me with a times x squared plus 2 quantity squared. My second term, x squared, would cancel. That would leave me with b times x squared plus 2 quantity squared. My third fraction, one of the x squared plus 2's would cancel. That would leave me with cx plus d, and then x squared and an x squared plus 2 to the first, and then an ex plus f times just x squared. So that's the next step. And then from here, I'm just going to try to simplify as much as I can. Unfortunately, because of this quadratic factor, I can't plug in some number like radical 2, because radical 2 squared would be 2, but 2 plus 2 is 4. So I'm not going to end up with a 0. So that's why we can't use that strategy here. Instead, we're going to have to use, we're just going to have to do the work. We're going to have to multiply everything out. So I want to start by just saying that x squared plus 2 quantity squared, because we're going to use this more than once, is x to the 4th plus 4x squared plus 4. So when I'm going through and doing my multiplication, I'm just going to reference that. So this is 8x minus 12. This first term is ax times all of that. So ax to the 5th. And then ax times 4x squared is plus 4ax to the 3rd. And ax times 4 is plus 4ax. Do the same thing with b. I'm taking b times x to the 4th, so that's bx to the 4th. b times 4x squared, so 4bx squared. b times 4 is plus 4b. This guy, because I've got x squared times x squared plus 2, I'm just going to rewrite this as x to the 4th times 2x squared to make my multiplication simpler. So now I'm going to multiply. Cx times x to the 4th would be cx to the 5th. Cx times 2x squared would be plus 2cx cubed. Next we have plus d times x to the 4th. and then plus d times 2x squared. And then we have the final two terms, which is ex times x squared, or ex cubed, and then plus f times x squared. Whew! So we have a lot going on. Let's go ahead in this case and simplify into combining like degrees. So I've got 8x minus 12 on the left. On the right, I'm going to start with anything to the fifth power. So there's 1, 2, and that's all. So I'm going to have a plus c x to the fifth. And now I'm going to look at to the fourth power. That appears to be all I have. So I'm going to have plus b plus, d x to the fourth. And now I'm going to look at third power, 1, 2, 3. So I have plus 4a plus 2c plus e x to the third. Now look for x to the second power. That gives me plus 4b plus 2d plus f x squared. And then I've got a 4ax, not the 4b. So plus 4ax, and then plus 4b. Woo! Look at all of this fun we get to have. Now, here's the first thing that's going to happen. There are no x to the fifth powers, so a plus c is equal to 0. So that's one equation. There's no x to the fourths over on this side. So again, that's b plus d is equal to 0. So that's going to help us once we start knowing what one of the values is. We can find the other value. All of this is x to the third, and so again, that's 4a plus 2c plus e is equal to 0. So all of those are equal to 0 so far. That leaves me with, and this one, because there's no x squared value on the left-hand side either. So 4b plus 2d plus f is equal to 0. So let's start with the two that we haven't even looked at yet. And the two that we haven't looked at yet is 4ax has to be equal to 8x. And so dividing by 4x on each side, I get a is equal to 2. So now I have that a is equal to 2. And let's go ahead and do 4b has to be equal to minus 12. So 4b equals negative 12. Dividing by 4 on each side, b is negative 3. And now those earlier equations are going to come into play, because if a plus c is equal to 0, and I replace a with 2, then c is equal to negative 2. And if b plus d is equal to 0 and b is negative 3, then d has to be positive 3. And I'm trying to find e, so let's use that third equation. That third equation says 4a, which is 2, plus 2c, which is negative 2, plus e is equal to 0. So that's 8 minus 4 plus e equals 0. So that's positive 4, so e is negative 4. And finally, we have for b, b is -3, so I'm using this equation now. 4b plus 2d plus f is equal to 0. That's -12 plus 6 plus f is equal to 0. So that's -6, adding it to each side, f is 6. So I've kind of run out of room here, but again, my final solution, I would write 2 for A, I would write -3 for B, I would write -2x plus 3 for CX plus D, and I would write -4x plus 6 for EX plus F. Coming up next, we have section 7.5, Systems of Inequalities.